Hi all, welcome back to the shop. Today I want to discuss about the way I design the axis, and more especially about the way it can move, and why I did make such design choice. So basically, on this machine there is 3 axes. On my machine, this longer one is the x-axis. Then you have the y-axis there, and that is perpendicular to the x-axis. And then you have the z-axis that supports the milling head, and you can see here. When you start a design of such machine, there is 4 solutions to make the axis moves. The first one is to use some screws, and there is 2 types of screws. The first one is that we can call the Acme screws, and the second one is ball type screws. They are very efficient, and especially for the ball type screws, and those one are used on the on a regular CNC machine, and I think it's a very great choice to make for the design. The only thing that could be for a hobby CNC a drawback is the fact that such screw cost a lot. So it's not necessarily very useful to spend a lot of money on screws and to not be able to make the rest of the machine. The second option that you can use is the rack and pinion that is also used on many plasma machines, also some professional machine. The third option is to use like it is make on a bike, the chain and roller. It works great also. And the last option, like on this machine, it is the timing belt pulley. If I make a zoom here, you can see that it's on all axes a timing belt. The timing belt has a big advantage. It does not cost a lot, and you do not have any backlash. And the backlash on a CNC machine is the enemy. So when you make your choice, be sure that you have no backlash, whatever the type of moving you are choosing. And I guess that the best one is the ball screw. The other one, you need to make some special design to avoid any backlash. And to go further on my machine, the way the axes are designed is always the same. There is a stepper motor that you can see here, and the stepper motor is mounted on this box, and this box is a reductor. The reductor is made with 2 timing belt pinion. Donc you can see the big one, and the small one was machined from a bar already having the tooth of the timing belt. You can see here. You can buy it with the number 2 you have, and it's aluminum bar, so very easy to machine. And with this kind of bar, you can make the needed pinion you want. You have also the same big one. I cut it, on my saw, and then I machine the face. I make a drilling operation, and then it's the beginning of the reductor. So I use a small timing belt. So the timing belt come in different things. So you have this one that is reinforced with some wire inside. I don't know if you can see the wire inside. You have this kind of timing belt. So this one is not. It's only rubber, I think, and there is no reinforcement inside. And you can also have some that we can call open timing belt, like those one. And I want to make sure that you can see the wire inside the timing belt. Not sure you can see. And the way the reductor is working is this way. On the big pulley, the timing belt is going around, and I use a small machine coming from this bar. So this one comes from the bar, and it goes the other side like this way. So the big advantage is that you increase the torque of your stepper motor, and you have a big torque on your axis. It's very simple to make, and the small pinion goes on the stepper motors like this way, and there is only one mounting screw. So all my axes are designed this way, and if we go back on it, so you can see on this when the big pulley, the small pinion is inside here, the pulley is around, the stepper motor is in the back here, and the outputs of the reductor receive another timing belt pulley, and then from this timing belt pulley you can move the axis in very efficient way with no backlash, and the backlash is the enemy of the CNC. So the Y axis is designed like that. So the Z axis, you can see the stepper here. I can make a turn to show you better. Yeah, you can see the reductor here, and this timing pulley for the Z axis that getting down for the milling head. And for the X axis, it's a double side pulley. So the reductor is there. You can see the pulley. You can see also the stepper motor with the cooling system, and there is two shafts that getting out of the reductor. One is getting on the left side of the machine, and the timing pulley is attached on the Y axis, and then you have a second shaft on the right side, also with the timing belt pulley that's going also to the Y axis. So it's the way I designed the machine, and I have two last things to show you regarding the design. So the data sheet of my stepper motors is this one. So it's a 4 Newton meters torque, and with the design of the reductor like this one, the torque is increased by around six times. So it's around 24 Newton meters torque on each axis. The other thing is about the accuracy. When you design such machine, you need to have a big accuracy. And if you look at the data sheet, you can see that this stepper motor has 1.8 degree by step. It means that you need to send 200 steps on the stepper motor here to make one turn. So you have to make a calculation with the reductor and the stepper motors to know how many steps you have for making, for example, 1 inch. So I use a data sheet for that, an Excel sheet, and on my machine, with the numbers of steps I use, and also the micro step that you can use on your driver, the stepper driver. On my machine, when there is one step, the axis is moving from 0.027 millimeters, and it's for the X axis, and for the Y and Z it's 0.025 millimeters. So it's a pretty good accuracy, and this way you can machine some precise things, and also it helps for very small parts. The only concern I have with the staples motors is the fact that when you increase the speed, the torque is decreasing. So you need to take care about that, and to find a good, let's say, Windows speed to have enough high speed when you make the moves, the rapid moves, but also to have enough torque when you make the machining operation. And with my machine, I designed it to have about a high torque between 600 and 1000 millimeters per minute of a travel speed. If you want to increase the speed, it is possible, but you need to change the reductor, and it will decrease the torque. And if you increase the speed on this machine too much, maybe around 2000 or 3000 millimeters per minute of travel speed, the torque loss is about 50%. So you will not be able to make the same deeper machining operation. So hope it help you if you need to make some design, and feel free to ask any question about the design. So thanks for watching.